Hey guys, what's up? I hope you're having a great day. Today I'm going to be going over Geometry Lesson 6-6. I'm sorry it's been so long since I've made a video. I've been really busy with homework and schoolwork, but hopefully this will help with your homework if you haven't done it yet, or with the test that's coming up. So what I want to start with, and what this entire video is going to be covering, is simply just the theorems. I made another video covering the examples that I'm probably going to put a link in the description, or I'll upload to Facebook or something. But this video is going to be covering the theorems, because if you can understand the theorems in geometry, you can very easily do the math. So let's go right in, and the first theorem basically says that if a kite is, if a quadrilateral is a kite, then its diagonals are perpendicular. So that's just kind of established for us, and we're going to have to take that one on faith. I don't have time to prove it right now. But basically what that's saying is, here's a kite, and this is one diagonal here, and this is another diagonal here, and it's saying that they intersect at 90 degrees, right? So each one of these angles are going to be 90 degrees, and that's what that theorem states. Because they're perpendicular, those angles are going to be 90 degrees. Now if you go down one, it says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So basically what that's saying, I'll switch colors here, is that in this kite, this pair of opposite angles is going to be congruent to this pair. And I'm actually going to prove that one for you. So let's take a look. From the previous theorem, we know that this is a 90-degree angle, and we know that that's a 90-degree angle. In addition, because it's a kite, we know that this side is congruent to this side, and by the reflexive property of congruence, we know that this is congruent to itself. So what we have now is that these two triangles that I've been working with, I'll go ahead and highlight them here. This triangle as well as this triangle are congruent, right? So these two are congruent. The same thing applies for these two triangles. So I'm not going to show you how, but it's the same. 90, 90, side, side, side. So we know that these two triangles are congruent. In addition, well, we know that, let me see here. Let's call this angle here angle 1. Let's call this angle 2. Let's call this angle 3. And let's call this angle 4. We know that angle 1 is congruent to angle 2. And we know that angle 2 is congruent to angle 1. Also, we know that angle 3 is congruent to angle 4, and angle 4 is congruent to angle 3. I don't know why I did those both twice, but that's what we know. So we know that angle 1 plus angle 3, so angle 1 here plus angle 3 here, is equal to this whole angle, right? So we'll call that whole angle W sub 1. We also know that angle 2 plus angle 4 is is equal to this whole angle here, which we will call angle 2 plus angle 4 is equal to W sub 2. Now we know that angle 1 is congruent to angle 2, so these are the same. And we know that angle 3 is congruent to angle 4, so we know that these are the same. So we know that W1 is the same as W2. And that's the proof for that theorem. Now that can be used in different ways throughout the book. Now you need to be careful. This angle here and this angle here are not congruent, okay? And that's simply because of the definition of a kite. Because this angle here, is not congruent to this angle here. Neither is this angle congruent to that angle, so that doesn't work that way. But that's how you're going to use it. You're going to be doing a lot of, you're given, let's say, this angle. What's the measure of this angle? And what you do is you add that 290 degrees and then subtract the sum from 180, and you're going to be doing a lot of that. But moving on, we're going to go and hopefully I'm not going too long here. I'm going to check 5 minutes, so I'll try and speed through this one for you guys. And it says that if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. Now let me show you. What that says is here we have this line is parallel to this line, and this line is congruent to this line. And what it's saying is it's saying that this angle is congruent to this angle, and this angle is congruent to that angle. Why is that? Well, it's because, let's take these two base pair angles, right? It's because of the hinge theorem. If you look back at page 340, I think, you will see the hinge theorem. And basically, if the opposite angle, or the opposite side, so this side here, is longer than this side, it affects the angle. Or if it's shorter, it affects the angle. But because this side is the same as this side, the hinge theorem is going to apply, and this angle is going to be equal to that angle. And you can look up the hinge theorem, and I promise you it's going to click with you. Also, these two angles are supplementary. And that's because if you extend that line and extend that line, here this becomes a transversal, and same side interior angles are supplementary. So what you have then is some angle plus another angle is equal to 180 degrees. So let's call this 1, 2, 3, and 4. We know that angle 1 plus the measure of angle 3 is equal to 180 degrees. We know that 1 is equal to angle 2 plus angle 4 is equal to 180 degrees. So we know that 1 is equal to 2, so 3 and 4 is going to have to be the same, because that is going to come out to be 3, and that's going to come out to be 4, and it's going to come out to be the same. In addition, we know that if a pair of base angles, so let's say this one and this one, if those are congruent, we know that the whole thing is a isosceles trapezoid. And in addition, this is going to be the bit of a more difficult one. We know, I'm sorry if this is going over, guys, we know that if it's an isosceles trapezoid, that this diagonal is equal to this diagonal. Now, why is that? Well, if you go over each triangle, right? Let's take this triangle. Alright, there we go. So this one, the black one I just highlighted, okay? Let's just ignore this other blue line. Just focus on this black triangle here. Alright, I'll highlight it in purple as well, just so you guys get it. This triangle here. Okay, this triangle has this angle, right? This is going to be difficult. Let's take a look at this other triangle as well. We're going to need to do it at the same time. I was trying to separate it, but it doesn't work that way. So you have this blue triangle and this purple triangle. In this purple triangle, we have this side is congruent to this side, right? And it's because if you look at only the blue triangle, this is one of the sides, right? And it's congruent to this side, which is part of the pink triangle, right? So we have two sides are congruent. We know that this whole angle, right? So look at only the blue triangle. This whole angle is congruent to this other angle over here, which happens to be one whole angle of the pink triangle. And in addition to that, they share the same base, right? So look at the pink, this is the base. Now look at the blue, this is the base. So we have side angle side. So it shows that these two triangles are congruent. Congruent parts, congruent triangles are congruent. So we have this diagonal is equal to this diagonal. So you have to visually separate all the different triangles. I hope this helped. If you're confused or have any questions or comments or videos you want me to make, I'd feel free to do it. I will definitely do it. In addition, there's going to be a link in the description to, in a few videos back, I said that a regular convex polygon, the number of sides was equal to 360 degrees divided by each exterior measure, exterior angle measure. I proved that, I showed you why, and you can go check that out. So thanks for watching, guys. I hope this helped. Bye.